So let's start. I'm starting with the thing that I forget to add to presentations, which is who is me. My name is Ilan. I'm coming from Israel. I want to tell you about 4 times I fell in love in my life. When I was 13 or so, I fell in love with the ZX81. That's how I learned programming for the first time. I dumped it after a while and fell in love with an Apple II, and that was awesome. And this is how I learned programming. That was really, I turned that into a profession. I became a programmer in '87. And although I'm not practicing programming a lot these days, unfortunately for me, I'm still very much in working with software companies. The second thing is I fell in love with my wife in the year 2000, and we have 3 adorable children most of the time. And we're doing dangerous things together. Then I fell in love with my 2 partners in Practical Agile that we established in 2012. We do consulting for organizations of various sizes, from small startups to the big companies like Cisco and Intel. And that's a lot of fun for me and for us. We also established Agile Practitioners Conference the same year. It used to be our conference. We gave it to the community 3 years later, and now it's a self-organizing conference. We are still members of the committee, but we don't make decisions. I'm a regular speaker at the Agile conference if the committee accepts my talks. And recently, we have a new baby born. That's Practical Software, where we decided to put our money where our mouth is, and we are developing software using the Agile mindset and practices and principles, and helping organizations learn to code better that way as well. One of the things we do is we provide cleaning services to organizations. That is, we'll clean the technical debt for you, and that way you can learn to adopt better cleaning habits. But enough about me. Okay, I'm going to start with 2 stories. These are true stories. They really happened. I was involved in both of them. The first story happened with the team that I was consulting to. They started from dire straits, and gradually they became a really excellent, hyper-productive team. They had good energies. And although the team was really great, the ecosystem was still not at the same kind of level. And this is like a prequel to the story that's going to happen. So they had a defect at a customer site. The product they were working on is with sophisticated algorithms for text and speech recognition. And the algorithms were not working at the customer site. So they were working on the bug. There was no opportunity for them to visit the customer. So they struggled with the defects this way and that. And it was a legacy product that was with a third party that was decommissioned. And then they said, hey, we have an idea. Let's take our latest technology and install it at the customer site. And then they will get the latest algorithms, which are much faster. They bring better results. And they will be able to use that. And we will gain experience with a new product that is not in the market yet. And the manager's response was, are you for real? Are you like little children? Do you know what this means for support? Do you know what this means for maintenance? Do you know how will this affect our contracts? Just stop with the nonsense and go and fix the bug. And they did. Disheartened, they went back and they fixed the defect. It took a while, and eventually they fixed the defect. And this is the end of the story. Well, it is really the end of the story. A short while after that incident, 2 teammates left the company. The atmosphere in the team was not the same. After a while, the Scrum Master went to another team. He did the same thing. He took a team that they were in dire straits, and he brought them to excellent results. But that team was not that team anymore. Here's another story. In that story, I was a developer. And the customer called us and they said, we have a huge problem. It was a huge, a big retailer in Greece with a huge store, huge mega store. It was before one of the major holidays in Greece. And the situation is that people come to the checkouts and the cashier scans the products and different products are coming in. So it's the store manager's worst nightmare. Not only that, the end of day procedure is taking 8 hours instead of 30 minutes, and then the system is not ready for the next day. So we try to look for what happened, and we have a hypothesis about a defect, and then we say, hey, we have an idea. Let's try something out. So we want to prove our hypothesis. We cannot work on the live system, so we traveled to the customer site. We took a PC next to the system, and we opened QBasic. This was 1992. And we started looking for evidence that will support our hypothesis. And hey presto, we found it. We found the bug. We fixed it. Then we turned to find what's wrong with the end of day. And the store manager and the head of IT in the company, they thought we were Superman. We were just fixing bugs. From our point of view, it was just fixing a problem. But they saw us as heroes. So what makes the difference between those two stories? Well, there are probably many things, but I'm going to focus on two aspects. On one aspect, and this is that. The environment we created was safe to fail. So what makes an environment that you work in to be safe to fail? So I'm going to look at two main elements. One is what we do is good enough for now. Remember that photo for a while, because I'll get back to that in a minute. So it's good enough for now. It doesn't have to be perfect. We're doing something that's good enough to pass to the next stage. That's one thing. The other thing is that it needs to be safe enough to try. Not like this one. Should be safe enough to try. And what we did things that are safe enough to try. And we had the sense and the acknowledgement that even if we do things that are not perfect in that retailer store, it will be good enough for now. And we felt safe enough to fail. So what makes things that are safe enough to fail and good enough for now? So a couple of years ago, I happened to hit a TED Talk by Gever Tulley. And he was talking about a book that he wrote, 50 Dangerous Things to Let Your Children Do. And he's talking about things like driving a car, like with a 10-year-old child, or operating heavy machinery, or playing with fire. There's a lot of learning to do with just playing with fire and learning how to control fire. And that hit a chord for me. First of all, I started to do more dangerous things with my own children, but also I thought, how about dangerous things you can do with your team? Now, Gever Tulley also, he has a school. He set up a school called the Tinkering School. And what they do in the school, it's a school that operates for 2 weeks. And kids come to the school, and for the first few days, they just take things apart and learn how they operate. And after a while, they have some ideas, and they start building things. And they use things like power saws and welding machines. And they build things that they have to climb up to do that. And they stand on a bridge that they built themselves, or stuff like that. So they are doing dangerous things. The thing is, in the tinkering school, you're doing things that are good enough for now. It's definitely not perfect, and they are safe enough to try. They are creating a safe environment. And this is what we want to create in our workplace as well. So let's make some sense of this. Just 1 second before that, what normally happens in our environment is we say, well, it's too dangerous for you to try. It's like that manager. What are you, like little children? Yeah, we are like little children. We want to try that out. Now, the reason that Kinder eggs are not allowed in schools is because children do get hurt from Kinder eggs. Yes? What we need to do is create an environment that's safe enough to try. That's why we have Kinder eggs, for God's sake. And by the way, the other thing you can't bring to school because we have no rules about that, at least not in certain states in the United States. So let's make some sense of this. And what I'm going to use is the Kinevin framework by Dave Snowden. And let's see how this helps us. Well, what Dave Snowden talks about is that when we operate in 4 types of systems that exist in nature. And those systems are, and I'll go one by one and give examples for each. The first one is an obvious system. An obvious system is a system where the boundaries are very clear. We know the boundaries and the limits of the system. And because we know the limits of the system, we can also tell what we can try and what we cannot try in the system. If we can try an example, tic-tac-toe is an obvious system. We know the rules, we know the boundaries, we cannot exist those boundaries. Alon, my youngest son, is 7 years old, and the other week he was doing tic-tac-toe, and then he did tic-tac-toe on his own. And he was playing against himself, and he said, well, at some point you can only reach a tie. Cool, that's a nice understanding, because that's an obvious system. The next system is a complicated system. It's a system where the boundaries are there. They are probably clear. Many times we don't know them yet. We might bring in an expert that knows the boundaries. If we take checkmate, we can bring an expert that knows the boundaries, but the number of moves in checkmate are finite. Yes? If someone is expert enough, he knows all the possible moves. Many times it will be a computer. The computer can know all the moves of checkmate, and then we know what the boundaries are. So either we bring an expert, or we write an algorithm that will find that for us, or we try something out to learn more about where the boundaries are, but still it's just a complicated system, which is something above obvious. The next type of system is a complex system. Here the boundaries are unclear, and they're changing all the time. So by the time we know what the boundaries are, if we try to find them, they've already changed. Reality has changed. So if we take an example, poker is an example of a complex system. The number of moves you can do with the card is limited and finite. The number of moves you can do in a poker game is infinite. So I can lose with something that I think is a great hand, and I can win with 2, 5, 7, 8, because I bluffed, because I'm good at bluffing. So the boundaries are potentially limitless. It just depends on the skills of the players and the knowledge. The next type of system is a chaotic system. Here, there are no boundaries. We cannot know the limits of the system. Yes? And we can't know how the system will react. Take an example. An example for a chaotic system is a sandbox. We can know how the children get in the sandbox. We don't know how it will end. Specifically, if we take tic-tac-toe, checkmate, or poker and put that in the sandbox as well, that will only increase the probability of a chaos. So these are the 4 types of systems. There are also 2 kind of temporary states that we can be in. One is the one in the middle, which is the state of uncertainty. We don't yet know what kind of system we are operating at. And what we want to do is to analyze and understand which kind of system we are acting in. Now, what we normally do, we start a new project and we say, hey, this is very similar to a project we did before. We just create a backlog if we're working Scrum, and we'll do some estimates, and we know roughly where this is going to go. We look at the system as an obvious system. And then we start working, and very soon after beginning, we understand that there are more things than what we thought of in the beginning. It's more complicated. So we move from an obvious to a complicated system. In reality, most of the time, when we start a project, we are in the complex domain. We still don't know what the boundaries of the system are. We don't even know how to know them for sure. So the best strategy that we can do is to run an experiment, find a little bit about the system, and then we'll find roughly where the boundaries are, and we'll continue doing that step after step, iteration after iteration, release after release. So we start with a complex system, and then we move between complex and complicated. At certain points of the project, it might become more complicated. We know more about the boundaries, and then something will happen. The customer will have new requirements, a bug will hit us or whatever, and then we'll go back to complex. That brings us back to that other state here, that cliff. If we treat systems as obvious from the beginning, we might fall over the cliff into chaos. We know when we're going to go into chaos, but we don't know how we're going to come out, much like the sandbox situation. So since we are a lot of our time in the complex domain, we want to learn how to make good experiments. Yes, and this is what we're going to do later. And with experiments, we can understand better where the boundaries are, yes, and that will give us information on what we want to act on later, which will lead us to the next set of experiments. So with that background, let's go and see what are 7 possible dangerous things you can try out with your team, or actually not dangerous things. Good enough for now and safe enough to try things. So, thing number 1, go and meet the customer. A company I used to work for, one of the things we did is when we were meeting the customer for understanding the requirements for the next release, we went with a few teammates. And we went there and met the customer. When we installed a new version in the lab, we went with a few teammates. And then they saw how the system is operating in the lab. When we installed on live, we went with a few teammates. And then they came back to the office, and the amount of learning from that was astonishing, because not only they learned about the habitat of the client, they also brought that knowledge back to the team, and they had discussions on that, and many ideas came out from that. So go and meet the customer. Dangerous thing number 2, install on the live system. Now, some of you may say, well, we're a cloud-based solution, and it's a multi-tenant system, and no way we're going to let anyone touch the system without automated scripts. Okay, fair enough. So how about a production-like system? Let them play with production-like. Let them install jars directly on the system. Let them change the scripts directly on the system. Anyway, it's going to be refreshed if you have continuous delivery next day. Or if you don't have continuous delivery, it's going to be refreshed before you release the next time. So let them play with the system. Let them fail. Let them feel what are the impacts of changing the system, and then lose the synchronization between development and live, and what's the impact of that. So they will have a sense of failing and sense of recovery. And maybe they'll have some decisions from that. For example, let them hack the build system. Let them hack the CI. Maybe the build is running for a long time, and they can improve the scripts. Maybe they have an idea for more tests to run on the system. Now, what I see happening in many organizations is that we have a team. Maybe they have their own CI system that they are working with. But ultimately, there's a team that's responsible for the CI system. So if they need to change the scripts, oh, you don't touch the CI system, it's too dangerous. There's a team responsible for that. Okay. So it's a dangerous thing to try to do with them. Let them change something. Worst case, they'll roll back to what it was before. Or let them just play around with it. For example, like this.
Just got notification that someone broke the build. You broke the build, Tom. Either that or you're listening to Kylie Minogue too loud.
Lady Gaga, man.
So, dangerous thing number 4. Let them hire someone. Or maybe for the more advanced ones, let them fire someone. There's a company in Israel called MyHeritage. They do genealogy trees. And one of the things they do is when they are hiring someone, they do a preliminary filtering by a manager and HR, and then they say, well, this looks like a good candidate. They bring it to the team. The team decides whether they want to hire them or not. And then they bring them to half day of fun. What's half day of fun? the candidate will come to the team, they'll code together, they'll see whether they're a good fit, they'll do some fun activity together, and then they'll decide. If they fall in love with one another, the new teammate and the team, that's wonderful. If they don't, they had a fun day together, and they part ways, and then they look for the next candidate. And that brings more, first, more trust between the new teammate and the existing team, and more trust between the team and the organization, who lets them decide who they're going to hire. For the more advanced teams that are already feel comfortable with bringing new people to the team, let them fire someone. Let them give them feedback about things that they are not doing well enough as expected. If that doesn't work enough times, let them make the decision whether the teammate stays in the team or not. Number 5, let the team decipher some legacy code. You know, that spaghetti meatball code that no one touches and no one dares doing something with it. Let's work with the team to try that out, to make changes in the legacy code. Maybe you'll want to create some tests as well. And if you find difficulties doing tests, well, you can buy a book like Working Effectively with Legacy Code and try to do something with that to work with the team towards improving this legacy code to become more testable. By doing something like that, it will be even more fun. It will be fun to take spaghetti out of this mess until it's tidy. And that also brings more proficiency to the team as developers, and their other code will also be cleaner, more robust, more maintainable, etc. Number 6, create an open source project. So maybe the teammates have an idea of a utility that they can create to make their life easier. Maybe some teammate has an idea of just something to do and don't have the time to develop it on their own. So invest 10% of the team's time, 5% of the team's time to do a team activity to develop something that's open source. If it's a utility that you do for yourself as development tool, and it's open source, and someone uses it and they tell you, well, we've tried this utility and it's crap. Awesome. You know maybe it was working for you, but someone else doesn't like it. You can ask them how to make it better, and then it will be better for the community. Or you can ask them, well, that's great feedback. How would you do it better? And then see how other members of the open source community contributes to your team, to your tool, sorry. Why that image? That's a GNU, of course. GNU is not Unix. And number 7, create your own tinkering school. Make a hackathon, or FedEx Day, or whatever you want to call it. Of course, it doesn't start with that. A hackathon doesn't happen like that. Tomorrow, lunchtime, we're going to start a FedEx Day, and we're going to work for 20 hours, and everything is going to be wonderful. It's something you work on for a while. You put some posters at work, we're going to do that. If you want to share ideas and create teams, and work in your teams what you want to do in that FedEx Day that will happen in 8 or 12 weeks' time. And it culminates in that day of high energy where everyone's working together, and that's awesome. The things that can come out of a hackathon, even if those teams are working on nothing related to your product or your workplace, it does wonders to how they work together afterwards, and the connections that become between people that may not even be on the same team on their day-to-day. So there you have it. 7 dangerous things to try out with your team. So what we're going to do now, just before that, let's recap. 7 dangerous things. Meet your customer, install on live, hack the CI system, hire someone or fire someone, work with your legacy code, develop some open source, and do a hackathon. Of course, these are just things that I picked up since I published the call for papers and until I made this talk about a month ago, but your things could be different. And this is what you're going to do now. You're going to make your own dangerous thing. So what I want you to do is to form pairs or threes that you're going to work in. So let's take a minute for that. Any pair that wants to take a third person to your team? Cool. Anyone else who doesn't have a pair? Great. So the first thing that you're going to do is think of an experiment that you want to try out and give it a name. What is the thing that you want to experiment about? A dangerous thing you want to try out with your team. Let's take 1 minute for that. All right. So next in your group, next what you're going to do, describe your experiment. What is it that you want to try out? Describe what is it that you want to try out with your team and what will be the experiment itself and the rationale for the experiment. Maybe you have a hypothesis on what will happen from that, or maybe you don't have a hypothesis and you just want to, you heard about something that worked for someone else and you want to see if it works for you. What's the rationale behind it? Again, take 1 minute for the description and the rationale. Okay. So, wherever you are is good enough for now. So your experiment was successful. You tried this out and it was successful. How do you know? What are the outcomes that you will see? How would you know that the experiment went well and the results are the kind of results that you want to see? So that's in the indications for success. And once it was successful, what would you do to maintain this success or to build on it? So if you want just to maintain it, what will you do to keep the momentum? If you want to build on that up, what would be your next experiment now that this experiment was successful? Again, take 1 minute to describe that. Okay. Again, wherever you are, it's good enough for now. It's good enough for today. I'm guessing you can guess what's coming up now. Your experiment has failed. How would you know that it failed? What would be the outcomes? Now, failure could be that you've set up the experiment and nothing happened. No experiment took place in the first place. And the failure can be that you've tried out the experiments and the outcomes are completely not what you wanted. Yes? So how would you know that the experiment has failed? Now, if it has failed, yes, and consider now that it has, how would you recover from that? How would you go back to where you were before? Or what would you do to dampen, to decrease the effects of this failed experiment? Take 1 minute again. All right. So now you know what will happen when your experiment is successful, and you know what will happen when your experiment has failed, and you are ready to try out your experiment. So what actions are you going to take? Yes. So what actions, and who's going to be responsible for those actions? Now, hint for you. Responsibility for actions, it must be someone in this room. So probably in your group as well, but if not, you can go to someone else in the room and say, hey, you're responsible for these actions. Are you ready to take it? So take 30 seconds or to 1 minute to say the next actions you want to do in order for that experiment to take place. Okay. So, as the saying goes, sharing is caring. Who would like to share the experiment that you are going to try out? Yes. Okay. So the experiment here is deploy on live and let the users test it. Okay, cool.
We were thinking on a completely different concept, so we thought that we could play Barbie Girl in the middle of a presentation. This
Okay.
See what sort of reaction we get.
Okay.
And we have our recovery plans.
Okay. So,
If we're from that.
so from now until the end of tomorrow, we can expect Barbie Girl playing in one of the presentations. We don't know which.
Maybe.
Maybe. Okay. Awesome. I love that. Yes.
To represent everything?
Well,
Just the idea, yeah?
whichever part you want to share.
We discussed that maybe we could just let the teams organize themselves. So one day, just ad hoc organizing. Just give them tasks. Well, there will be a backlog. So anyone can organize themselves in whatever team, size, type, whatever, whoever they want to, and just work on what they want.
Awesome. There are people here in the conference who have experience with that. I have experience with that too. So you can find people for that and ask them how to do that successfully, and I'll be happy to help. Yes? Let the teams decide their own holiday policy. Cool. And one more? Choose which one? Yes.
Work experience for developers. Developers have to go out and do their user's job for a week.
Do the user's job for a week. Yes, that's great. You know, I used to work for Tesco's for a few years. And one of the things they do with the postgrads is the postgrads go to work in the stores for a while. They're doing shelves and working on the checkouts and working in the warehouses. And only then they start to work in IT. So, yeah, that's great. I think I'll open it up for questions, if you have. And if not, let's hear more experiments.
Question, how do you get the money required? So you come up with an experiment, go for it. You know, I would go for the same team, okay, let's go for it. But you need to get that buy-in.
Right.
Their steps.
Right. Well, you need budget. So you need to go to the managers and get some kind of budget. So what I will do is if you get a no, and that's kind of an experiment that failed, you can start with something more humble. Yes? Start with 20 quid. What can you do with 20 quid? And see how that goes. And when, if that failed, okay, so what can I do to do another experiment? Well, maybe it was a bad idea for this company. And if it succeeded, or after you tried it several times and then it succeeded, then you go back to the manager and say, look, we invested 20 quid and we've gained 1,000 pounds worth or 10,000 pounds worth because of the effect. And then you're going to go for the next experiment. That would be a good strategy for continuing to the next experiment. More questions or sharing experiments? Pardon?
With the aim of taking down live system. See how it runs.
Okay. Is it safe enough to try? Find out. Those words indicate that it's probably safe enough to try. Yes? You know, I'll take it to the extreme. Even if you lose your job, yes, because of that. If you felt it's safe enough to try and you're willing to take the risk and then to find another job, yeah, that's safe enough to try. But I'm saying it with all seriousness, because if the organization is not safe enough to try, there's a saying that goes, you either change your organization or you change your organization. Yeah, so if it's burning in your fingertips that you want to experiment with things and you are unable to do that, create your own environment that you can do that. All right. Thank you very much. So, one slide that I forgot, just for the excitement, just parting thoughts. This is a quote by Michelangelo. The greatest danger for most of us is not that our aim is too high and we miss it, but that it is too low and we reach it. So again, thank you.